The basic form of the square root function is y is equal to the square root of x. Note that because we've written y equals the square root of x, we are implying the positive square root and not the negative square root. This rule, y equals square root of x, implies that x must be greater than or equal to 0. It's allowed to equal to 0, the square root of 0 is 0, but it can't be negative because we can't get the square root of a negative number. And because we've asked for the positive square root, y will be greater than or equal to 0. And here we have the shape of y equals to the square root of x, this dotted line here. And like in previous videos, we're going to consider what happens to the point when x is 1 and y is 1. The power form of this function is very similar to the others. Y is a outside of the square root of x minus b plus c. As I change the value of a, let's have a look at what happens to the graph, and in particular the point 1, 1. You'll see that like all of the other graphs we've looked at, the A value changes the dilation, it changes the thick and thin of the graph, but it dilates or magnifies that point along the y-axis. So again, let's have a look when A is 2. B is 0, so x is 1, so we get 2 times the square root of 1, which is 2, and that's why this graph moves up here, or this point moves up here. Again, if A is negative, we will get a graph which is flipped across the x-axis and looks like so. As with all of our other power functions, we would expect that changing the value of b moves the graph left and right, and here we can see that changing the value moves the graph left and right, like so. Let's have a look at this point here though, where b is 4. We'll see that the graph doesn't start until x is equal to 4. So in this situation where we have y equals the square root of x minus 4, x cannot be any value less than 4. And if we think about this for a minute, if we have the square root of x minus 4, if x was say 0 or 1, then we'd end up with a negative value in here, and we can't have the square root of a negative value. So this value here inside the square root sign must always be positive, and that's why these values of x are not allowed. Let's set it back to 1, just move our b back to 0. Let's have a look at what happens as we change the values of c. As with all of our previous, we would expect that the values of c move the graph up and down or translate it along the y-axis, which is what we can see here, translation. Going back to our summary, the power form of the square root function is y equals a outside of x minus b plus c. This plus c is outside of the square root sign. This implies that x must be greater than or equal to b, and that y will be greater than or equal to c. There are no asymptotes with this graph. The domain of this graph is all the x values where x is greater than b, or we can write that in interval notation as such. And the range will be all y values where y is greater than or equal to c. And of course, what I was just showing you, the range here, is if a is greater than 0. If a is less than 0, then as we saw from the graph, when a is less than 0, the y values are negative. They're flipped across the x-axis here, they're negative. So when a is less than 0, the range will be all the y values from negative infinity up to and including the value of c.